Now we're going to take a look at parts C and D of 2016, number 1. Part C, we're supposed to use our answer that we got in part B, which was that the amount of water removed over that time period was 850 liters. We're going to use that answer to find an estimate for the total amount of water that's in the tank at the end of the 8 hours. So what's going on is there's water that's being removed from the tank, but there's also water being pumped into the tank at the same time. So to get the total amount of water, or the actual amount of water in the tank at the end of the 8 hours, we have to take the amount of water that initially was in the tank, which was 50,000 liters, plus the integral from 0 to 8 of W of t, which will give you the amount of water pumped into the tank over that time period, minus R of t, which gives you the amount of water that has been pumped out of the tank. Okay? So that ends up, we just will punch that in our calculator. We'll put W of t, which is 2000 e to the negative x squared over 20. I'm going to put that into y1 in my calculator. Then I'm going to go to my home screen and do the integral from 0 to 8 of y1. And that'll come out to be 7,836.195 liters, and that would be the amount of water that's pumped into the tank over the 8 hours. We already had known that 850 was the number of liters that was removed. So adding and subtracting all this together, we end up with 49,786 liters of water in the tank at the end of the 8 hours. So for the points, 2 points for part C, 1 point for writing this integral, and 1 point for your estimate answer. So now in part D, from the time 0 to 8, is there a time t when the rate at which the water is pumped into the tank is going to be the same as the rate at which the water is removed from the tank? So in other words, is there a time in which W of t is equal to R of t? If we had equations for both, it'd be easy. We could just graph them and see where they intersect. However, we don't have an equation for the one. We don't have one for R of t. So we're going to look at W of t. If W of t equals R of t, that means that W of t minus R of t has to equal 0. So what we're going to take a look at is we need to figure out, is this ever going to equal 0 when I subtract these two? In other words, when they're equal. Well, one way I could know that was if W of t minus R of t changed from negative to positive, it would have to equal 0 at some point, or positive to negative, it would have to equal 0. And that sounds, I hope you recognize the intermediate value theorem. I hope you recognize that. And so what we have to do is determine that. Well, we know that at 0, W of 0 minus R of 0, we know that W of 0 is 2,000 because we can just plug it in to the equation. E to the 0 is 1, so W of 0 would be 2,000. We're told in the table that R of 0 is 1340, so 2,000 minus 1340 is greater than 0. So W of t minus R of t is greater than 0 at 0. Now, if we can find a place where it's ever less than 0, we know it has to be 0 at some point. So we go to another value that we know. We know R of 8 is 700, and we know that W of 8 is 81.524. And how do we know that? Well, we punch that in our calculator, but we also, before we would punch in our calculator, why did I choose 8? Because R of 8 is 700, and if you think about plugging in W of 8, you got 2,000 times e to this power, so we just have to check it out in our calculator to see. So y1 of 8, y1, remember, was W of t is 81.524, and so W of 8 is 81.524, subtract R of 8, which is 700, you're going to get a number that's less than 0, because 81 minus 700 is obviously less than 0. So that means that W of t minus R of t, because it's differentiable, which implies that it's continuous, which is the hypothesis of the intermediate value theorem, and I have to state this, by the intermediate value theorem, then there has to be a time t where Wt minus R of t would equal 0, and thus W of t equals R of t. Or the rate the water is pumped in equals the rate that the water is pumped out. And there's probably a lot of different ways that could be arranged and organized, and I might not have done it the best, but that's the idea behind what you have to do there. You have to use the intermediate value theorem, and you have to state the hypothesis. And you're going to have to state at a point, where one point where W of t minus R of t is negative, and one place where it's positive, and so that it has to change sign, and thus be 0.